Good morning, students. Chapter 11, Thermal Properties of Matter. We will see some examples. See, first example, you are given combination of two rods, one of steel, one of copper, and one junction is formed. Between them there is insulating material, so no heat transfer takes place from this region. Okay, one end is at furnace 300 degrees Celsius, other end is at ice box 0 degrees Celsius. Okay, and yes, with the help of these two rods, one junction is formed. What is temperature of steel copper junction in the steady state? Junction means, see, it is steel wire. Its one end is at 300 degrees Celsius, another end it is in contact with this copper wire. This copper wire, its another end is at ice box, that is at 0 degrees Celsius. So yes, it is called junction. It is called junction. Your question is, what is the temperature of steel copper junction in the steady state? So I am assuming that temperature of this junction is T0. Temperature of this junction is T0. So first of all, you have to assume that temperature of junction is T0. Okay. Yes, you are given data LS, that is length of steel wire 15 centimeter, length of copper wire 10 centimeter, thermal conductivity of copper 385 SI, area of cross section of steel is twice area of cross section of copper, thermal conductivity of steel 50.2 SI. You have to find what is temperature. One word, what is meaning of steady state? Yes, meaning of steady state is heat current through any rod or compound rod, it remains same. So what is meaning of steady state? Steady state, it means steady state means it means H through this steel wire, H through this copper wire, H through this compound wire, it remains same. Okay, H is same. H means heat current. H means heat current. And what is equation of heat current? We know that. Okay, H is equal to, that is heat current is equal to, it is Ka T1 minus T2 upon L. H is equal to, it is Ka T1, that is temperature of hot end, T2 temperature of cold end, L that is length. Okay, now steady state. So in this case, what is meaning of steady state? So in thermal steady state, I can write heat current through steel wire is equal to heat current through copper wire. So how to write this equation for HS? See how to write equation. Here it is. It is Ks AS. Now for steel wire, it is one end, it is another end. Obviously, it is end with higher temperature, it is end with lower temperature. So it is 300 minus T2. It is 300 minus T2. Any doubt? Okay? Okay. It is 300 minus T2 divided by its length. That is LS is equal to this side HC means heat current through copper wire, so it is AC for this copper wire. Here it is 0 degrees Celsius, here it is temperature T0 means it is temperature of hot end, so it will be T0 minus C. It will be T0 minus C divided by it is S. Any doubt? Okay, easy. Yes, it is easy. Let me check it is visible or not. Yes, it is clearly visible. So now what to do? So yes, now what to do? So we have to put values actually. Okay. See Ks. Where is Ks? Here it is 50.2. 50.2. As I can write this as 2 AC. So it is 2 AC. I can write it as 300 minus T0 divided by LS. LS means it is 15 is equal to KC. KC is 385. 385. AC as it is. Here it is T0 divided by. Okay, divided by. Divided by it is LC. LC is here it is 10. Here it is 10. You see? Okay, so see here it is AC cut. AC cut. Now remaining terms you have to simplify. Okay, like this. Okay, for example, it is 50.2. 50.2 into 2 is equal to divided by 15. Divided by 15. So it is 6.693. It is 6.693. In bracket, it is 300 minus T0 is equal to this side. So yes, it is obviously 38.5 T0. And it out. Now if you multiply this in bracket, so it is into 300. So is equal to it is 2008. Yes, it is 2008. So it is 2008 minus 6.693 T0 is equal to this side it is 38.5 T0. 38.5 T0. Now if I take this term this side, then I can write 2008 is equal to 38.5 plus 6.693. So is equal to it is 45.193 T0. And therefore T0 is equal to 2008 divided by 2008 divided by 45.193. So it is equal to it is 44.43. Yes, it is 44.43. So your answer is 44.43 degree Celsius. It is temperature of junction. Yes, it is temperature of junction. So yes, what is meaning of thermal steady state? That you have to understand. In thermal steady state, H is same from first wire, from second wire, or from composite wire. Clear? Okay. Yes. Remember equation of H. Ka T1 minus T2 upon L. K thermal conductivity. A cross sectional area. T1 temperature of hot end. T2 temperature of cold end. L that is length. Simple. Put value. You can easily calculate this one. Okay. Now second question. What is second question? So see, data is given on board actually. Yes, data is given on board. K, you are given 2 bar, 1 iron bar and 1 brass bar. Length of iron bar 0.1 meter, cross sectional area 0.02 meter square. Its thermal conductivity K1 79 SI. Brass bar, its length L2 is equal to 0.1 meter, cross sectional area 0.02 meter square. And thermal conductivity 109 SI. You are also given figure. Okay, they are soldered at one end. Okay, it is iron bar, it is brass bar, and there are 2 free ends. They are maintained at temperature 373 Kelvin, and here it is at 273 Kelvin. So yes, you have to find 3 questions. First, obtain equation of temperature at junction. Equation of temperature at junction. Equivalent thermal conductivity and heat current through the compound bar. Yes, you have to obtain equation of these 3 things and also their values. So yes, how to find this question? We will find this question. We will find this question. How to find this question? Here, okay, first of all, obtain equation of temperature at junction. Yes, you are given this system is in steady state. So for thermal steady state we can say, for steady state we can write this equation as, hello, yes, as, see, for thermal steady state, how to write? For thermal steady state I can write heat current from ion, that is H1, you are given names 1, that's why, and heat current from brass, H1 is equal to, it is H2. H1 is equal to, it is H2. So now what is equation of H1? With the help of this equation is K1 A1. As you have to find what is equation of temperature at junction, I am assuming that at this junction temperature is TO. At this junction temperature is TO. So how to write T1 minus TO? T1 minus TO divided by L1. Any doubt? Hello? Any doubt? Okay. Is equal to H2. What is equation of H2? So obviously it is K2 A2. Here for second wire, obviously it is T0 minus T2. It is T0 minus T2 divided by, here it is L2. Divided by, here it is L2. Now see in given data, L1, L2, they are same. So yes, I can write here L1 is equal to L2. Also, A1 is equal to A2. A1 is equal to A2. So yes, I can say as L1 is equal to L2, A1 is equal to A2. Simple. Okay. The remaining terms I can write as K1 T1 minus T0 is equal to K2 T0 minus T2. Now simplify this. K1 T1 minus K1 T0 is equal to K2 T0 minus K2 T2. Now as we have to find T0, I can write this term on right side and this term to left side. So I can write it is K1 T1, this term here, plus K2 T2 is equal to K1 T0 plus K2 T0 plus K2 T0. So from this I can take T0 as common. Okay, so I can write it is K1 T1 plus K2 T2 is equal to T0 common. Here it is K1 plus K2, and therefore what is T0? So T0 is equal to, it is K1 T1 plus K2 T2 upon K1 plus K2. So it is equation of temperature at junction. It is equation of temperature at junction. Clear? Okay, so yes, you have to remember this equation for this question particularly. Okay, so now see, if you want to obtain its value, then how to find K1? Here it is. T1, here it is. K2, T2 divided by K1 plus K2. So you can easily find its value. Yes, you can easily find its value. We will find values at last. First of all, we will derive all equations. Okay, chalo. How to obtain second equation? How to obtain second equation? You have to find equivalent thermal conductivity. Equivalent thermal conductivity. Now, what do you mean by equivalent thermal conductivity? See, this iron wire is of length L1, brass wire is of length L2. Area of cross section A1, area of cross section A2, thermal conductivity K1, thermal conductivity K2. From this we can see that the lengths are same, their cross sectional area also same, but the thermal conductivity different. So we have to obtain, we have to find equivalent thermal conductivity. For that, see, I can see a series connection of two bars. Series connection of two bars. Okay, if they are equivalent, okay, let composite bar is like this. It is the composite bar. See, the cross sectional area same, so I can say it is cross sectional area A, that is same. And yes, you can write A1 or A2, anything. Okay, length, so its length will become 2L. Yes or no? Its length is L1.1 and its length is L2, that is 0.1. So the length same. So I can say it is 2L. Yes or no? Yes. Then I have to find what is its thermal conductivity. K dash is equal to what? K dash is equal to what? Yes or no? Yes. Or if I want to represent each and everything, that it is K dash, that it is A dash. Okay. Let this composite bar having cross sectional area A dash, length L dash, and thermal conductivity K dash. Then how to make relation? See, as these two bar they are in series connection and it is its equivalent, with the help of equation of resistance I can write, okay, let resistance of composite bar is RH. Then I can write, okay, RH is equal to RH1, that is resistance of this first wire, plus RH2, resistance of this second wire brush. Now RH, what is equation of R? Hello, what is equation of R? R is equal to, it is L upon Ka. Yes, thermal, here I will write data in bracket, thermal resistance, its equation. So say thermal resistance, its equation is RH is equal to L upon K. So chalo, for composite bar we can write it is L dash upon K dash A dash. For first it is L1 and it is L1 K1 A1 plus L2 K2 A2 and down. But see here L1 is equal to L2, A1 is equal to A2. L1 is equal to L2, A1 is equal to A2. Any doubt? Sure. Okay. Sure. L1 is equal to L2, A1 is equal to A2. So now how to write this data? L dash, that is length of this composite wire. This length is L1 and this length is L2. So I can say that L dash is equal to, it is L1 plus L2. But as these two lengths are same, I can write it is 2L1 divided by K dash. A dash that is cross sectional area of composite bar is equal to area of cross section of this bar as well as this bar. So I can here say it is A1 is equal to as L1 is equal to L2 and A1 is equal to A2. I can write them common. So it is L1 upon A1. So in bracket it is 1 upon K1 plus 1 upon K2. Hello. As L1 is equal to L2 and A1 is equal to A2, I can write this L2 as L1, A2 as A1, and then I can take them common, direct step. Okay, you have to understand. So now L1 cut, L1 cut, A1 cut, A1 cut. So it is 2 upon K dash is equal to 2 upon K dash is equal to, how to simplify this? It is K1 plus K2 upon K1 K2. So if you make K dash as subject, so therefore K dash is equal to, it is 2 K1 K2 upon K1 plus K2. Yes, you can easily find its value. You can easily find its value. Clear? Okay, so yes, K dash is equal to, it is 2 K1 K2 upon K1 plus K2. You can easily find its value. You have to put just values. So two questions solved. Okay, what is thermal conductivity? Now next, what is heat current through the compound slab? You have to find, okay, what is heat current through the compound slab? Yes, you can find it with the help of three equations. Yes, okay, heat current through compound slab. Heat current through compound slag. How to find? As it is in steady state, you can find it in any manner. Okay, you can say, okay, yes, H1 is equal to H2 or is equal to, you can use this equation. So I will give you option. Okay, you can use this equation H1, that is for this wire, that is K1 A1 T1 minus T0 divided by L1, or H2 is equal to K2 A2 T0 minus T2 divided by L2, or H composite wire, that is K dash. A dash is equal to, here I'm not writing exactly to, okay, all these things. Okay, K dash is equal to, okay, here A dash is equal to A1 is equal to A2. Okay, L dash is equal to, it is L1 plus L2, it is L1 plus L1, means it is 2L2. Okay, yes. Okay, yes. Here it is L1 plus L1, means here it is 2L1. Okay, and yes, we also have one value, that is, we also have one relation, that is L1 is equal to L2. So remember this thing directly. Okay. Now X is equal to, it is A dash. Here it is T1 minus T2, and divided by, here it is L dash. Here it is L dash. So yes, with the help of any equation, because now you have each and every value. Okay. Yes. From this equation you can find what is value of T0. From this equation you can find what is value of K dash. So if you put value in any equation, you will get your answer. Yes, you will get your answer. Okay. So yes, it is one important question. And the equation, yes. So yes, it is one important question. Clear? Okay. Let me check what is time of lecture. Then I will see, okay, what next to do. Okay, it is almost 22 minutes. So I think this is it for today. Next questions we will see in next lecture.